And welcome back to this RS series in JavaScript. And today we have another interesting question that we have to find whether there is two elements whose sum will be quite equal to the required sum. Like you have to find two elements where you will be given an array and a sum. So you have to find whether is there any pair, two elements whose sum will be equal to the s. For example, if this is your input array, so I can say over here I need 7. No, 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 no. Okay, so I can see this is one pair, 2 plus 5, 7. 6 plus 1, 7. So these are the two distinct pair. Okay. Okay, so how do we do this? Method number one. Very brute force. So what we will do, we will find all the distinct pair. Find all the distinct pair. Find all the distinct pair. And check whether sum is equal to like required sum or not required sum. If it is equal, then return that pair. If it is equal, then return that pair. That's it. Or like you can add all the pairs into an array, and then finally you will return that array, whatever that question will say. Okay, so we'll focus on the concept over here. Okay, so how do we do this? So let's start for loop. Very brute force. So let I is equal to 0, I less than n, I plus plus. We need to find all the pairs, all the pairs. Okay, so like first number. So first we'll get pair with these 1 2 1 5 1 6 1 1 1 8. 2 2 will get pair with 2 5 2 6 2 5 will get pair with 5 6 5 1 5 8 6 6 1 6 8 1 1 8 1 8. Will 8 be paired with anyone? No, because its pairing is already done with all other pairs. So I can say that uh, let j will start from where? J will start from I. Like if I need to say j will start from where? 1, 2. Okay, no, wait. 2, 2's pairing. If your I is this, then j will start from here, right? So I can say I plus 1, and j will go till where? J will go till here because it goes till here. So j less than again n, j plus plus. Okay. Now we need to find the sum of sum. If array of I plus array of j, है ना, 1 2 1 5 1 6 1 1 1 8 2 2 2 2 2 है ना 8. If I is equal to n, j equals to n plus 1. No, this loop will end. Okay, okay. So fine. So this is the sum. If this sum is equal to what? Equal to s, then let's suppose you have a result dot push I comma j. So this is it. And at the end you will return, at the end you can return this result. If you talk of the time complexity, yeah, there is a nested loop, so time complexity will be big of n square. Space complexity, yes, we are consuming a result array, so space complexity will be uh, at max we can at minimum we won't find any pair. At maximum, like all the different pairs possible, all the possibilities can be, isn't it? So I can say at max will be nc2, n is there, all the different possibilities. Okay, or to be more, in general, so big of n. Okay, so this was your brute force. Now let's, we need to improvise this n square. So let's go to the method number 2. Now this method takes us to hashing. This method takes us to hashing method. Okay, now let's understand this. Suppose you have input array 1 2 5 6 1 8. Okay, and if your sum is, let's suppose, 7. Okay, now if I talk of 1, 1 if 1 is there, then s minus I, like sorry, a of I, like for example, if this is a map, okay, this is a map. What I will do, I'll like what I'm trying to say is I'll store all the elements with index. I'll store all the elements with index. Like for example, is 1, then s minus 1, that is 7 minus 1, 6. If 6 is present, no, it is not present. That means there is no pair possible. So we will store element with index 0. Let's take the second element. 2. 2. Is any pairing possible with this? So what we will do? We will check the previously. We will check what is required to make it 7. So 7 minus 2 is 5. So is previously 5 present? Is previously 5 present? No, it is not, right? Then we'll store this with index. Next we have 5. Now to make this pair 5 equal to 7, so we need how much? 7 minus 5 equals to 2. Okay, is there 2 present in the map? Yes, we have 2. Yes, we have 2. That's what now. If it is present, then I can say the pair will be these two. If it is present, then we have a pair. Then I can say that yes, there is a pair possible. Then either you can, either you can push into the array result as we did in method 1, and we will keep moving forward for another pair possible. And if it is like only one pair possible, then we can return yes, and we can return the, so I can say the result dot push. So one index will be I, and another will be map dot get what, map dot get this one. So map dot get s minus a of I. So we will push into the, and at the end we can return this result. Again, another element we will have 6. Is 6 possible? 6 required is 7 minus 6, 1. 1 is it 1 possible? Yes, we have 1. So we have another pair. We have another pair 6, so this way it will keep on going, isn't it? Next can be, okay, let me take this case. 6 is possible, so I can say that 6 is getting paired with 1. So 6 is getting paired with 1. 6 comma 2, this is another pair, and we had here 2 comma 5. Now 1, the next element is 1. Now to make it 7 we need 6. So this is also possible. 6 comma 1, sorry, 6 comma 1. So I can say there's a duplication happening over here. So if duplication is happening, then what we can do, if duplication is happening, to avoid duplication, if you want unique pair, then instead of taking this result, we could use a set. We can take a set. Now this will be a homework for you. So instead of taking this, we can, like, if it is a completely distinct, then you can use set, and I think you can very well know how to use this set. Okay. So this was your hashing method. Let's come to the coding part. Let's come to the coding part. Okay. So we have a function to some problem, and you will be given an array and with a sum s. Okay. For let I is equal to 0, I less than n, I plus plus. And now the loop starts. So let k is equal to s minus a of I, isn't it? So if we will check if it is present, map is if this element is present or not. If not present, then what we can do, we can result dot push. Sorry, if it is present, right? If it is present, then what we'll do, result dot push what, I dot map dot get array of I. Okay. Else we need to set the elements a of I with index, isn't it? So at the end you can return the result. Okay. So if I talk of the time complexity, then big often time complexity will be big often, and space complexity. Yes, we are using a space to store the index, so I can say big often. If it was that you need to return the result uniquely, then you can use set, or you can apply some other logic to make it distinct. Okay, so this was your method number 2. Method number 3. Method number 3. Now this comes to the best method possible is your greedy algorithm, or like two pointer theorem. Two pointer theorem. So you have this 1 2 5 6 1 8. Okay, so this was your input array. What I will do, I'll first sort it. Let's sort this array. So 1 1 2 5 6 8. Okay, now you want sum to be 7. I'll take two pointer. One pointer here, left pointer, and right pointer over here. Okay, and you add them. So I can say this is a left pointer, this is a right pointer. Now you add them. So 1 plus 8 is equal to 9. Oh, sum is greater than the sum is greater than the required sum. Okay, what we will do? If it is greater than, then if I shift this towards, so we are moving towards higher element, then this sum will increase. Then that means this is not correct. So we need to move this pointer towards left, because if it is 8, then we need to move towards the lesser element, then only the sum will decrease, isn't it? So that means I can say that if the sum of left and right pointer is greater than the required sum, then we need to uh, left move the right pointer towards left. If the sum is less than the required sum, that means I need to move the left pointer towards right. Then a point will come. Where I can say the sum of left pointer plus right pointer will be equal to the sum. Now we got the required target, and we got our pair. In this case, we can do result dot push L comma R. Result dot push. So this is two pointer theorem, that we take 2 points. So one is left pointer, right pointer. We'll add them. We'll compare with the S. If it is greater, move the right pointer towards left. If it is lesser, move the left pointer towards right. If both are equal, sorry, if sum of both the left and right is equal to S, just add to the result. Okay, now let's go to the coding part. Very easy. Array dot sort. Now this is, we got the elements sorted in ascending order. Now let's take the left pointer. Let's write L only. Okay, left pointer will be equal to 0, isn't it? Right pointer will be equal to what? Array dot length minus 1 to the extreme right, while what? Left is lesser than right pointer. We'll start the iteration. First condition, if array of length plus array of right is equal to S, that means you got it. Result dot push what? L comma right. If array of length plus array of right is greater than sum, then you remember we need to move the right pointer towards left. If array of length plus array of right is less than S, that means what? We have to move the left pointer. So this will work, and at the end, once we come out of the loop, return your result pointer. Okay. So if you talk of the time for complexity, a simple single iteration is performing this, but before that we are doing a sorting. So sorting takes n log n. So time complexity n log n sorting takes plus a single iteration is being performed. If we talk of the space complexity, yes, we are using a result, so big of n. Okay, so much better approach than n square. So I hope this two pointer to some problem is clear. If you're thorough with this, try to code yourself. Try to, dry run, write and practice. Things will be more clear. Okay. Thank you all. Have a great day. If you really like this, subscribe to this channel and stay tuned for another interesting question. Thank you.